Here with the combined section 2.2 and 2.3. That being said, this is going to be a little bit on the longer side in terms of the number of problems, but not quite as time consuming as some of our other sections. And so the number of problems here is deceiving in terms of how long this is going to be because they are all relatively quick. So one thing that I do want to draw attention to very early on is that we are now using quadratic functions to solve problems associated with business. In chapter 1, we were using linear functions to do that. And to be honest, linear functions are sort of a terrible model to use when modeling things like selling a product or market equilibrium and that sort of thing, because those things tend to not follow a straight line. So these quadratic representations are much better. They are more complicated to solve. So again, hallelujah that we have Wolfram to do the math for us. And if you're a person that wants to do this by hand, I will not stop you, but I will wish you luck. So that being said, everyone, our purpose today is to solve problems that can be modeled by quadratic equations. And a quick review in Schlegel notes here, we need to remember that profit is equal to revenue minus cost, that revenue is the price times the number of units sold, and that there are two ways to find the break-even point, and those are that when revenue is equal to cost and when profit is equal to zero. Next, in our Schlegel notes here, we do have this idea of maxima and minima. And so if you think about a soup bowl or a cereal bowl sitting on the table, it would have a shape sort of like a smiley face. And there is definitely a bottom to that cereal bowl. We would call that, if we were to make a graph that looked like that had sort of a smiley face shape, we would call the point that's at the very bottom the minima. That's the very bottom, the least. And alternatively, if we were to flip that bowl over upside down, it would have an arch sort of like the top of your head or the top of a tire. And it has a definite high point. We call that definite high point a maxima, and that's the very, very top. In real life application, we can refer to or think of the maxima and the minima as a lot or a little, and the top of the curve or the bottom of the curve. Now, mathematically, the way that you may have found these points before is by using a formula, negative b over 2a, and we could do that, and I have done that in the past, but I have found a easier method is just in Wolfram, type the word maximize. And so you'll see an example of that in just a couple minutes. But maximize, we're gonna type the word maximize and then put the equation, and Wolfram will handle it from there. Again, this course is not about necessarily doing math as much as it is using math to make decisions and decide what we should do with our business. So a little in the small fine print there, we could type minimize also. Wolfram would also find a vertex or a low point if we typed in minimize, but there is no business application for minimizing stuff. And so therefore we're not ever going to do it. And we'll talk about that in further discussion as we go forward. But obviously you do not want to minimize your profit. That would be making yourself go bankrupt. You do not want to minimize your revenue. That would also make you go bankrupt. And believe it or not, you do not want to minimize your cost either. And we'll have a conversation about why minimizing cost would be a bad thing as we move forward through some of these problems we're about to do. So with that, everyone, that's the quick introduction to section 2.2 and 2.3 combined. This video is obviously here, and we'll be back with the next video for example 1.